Yeah, good afternoon, everyone. So, today we are going to discuss a new topic. It is called electric dipole. Actually, this topic is very much important in board exams as well as competitive exams because we can expect some questions in board exam. We can expect some essay questions or 4 to 5 mark questions, and in entrance exams also we can expect one question from the point of electric dipole. So without wasting time, I am directly going to the topic electric dipole. So today my aim is to cover what is an electric dipole and electric field due to electric dipoles. So first, what is an electric dipole? What do you mean by electric dipole? What do you mean by a dipole? Simply, electric dipole, two equal and opposite charges which are separated by a small distance is called an electric dipole. Two equal and opposite charges which are separated by a small distance. Magnitude wise it is equal, but the sign is different. Two equal and opposite charges which are separated by a small distance is called an electric dipole. Actually, the distance between them is very small. If you see the real life example, it will be the order of micrometer, or nanometer range. So it is very small distance. I am representing it is as 12. So at that time, the students can ask, "Sir, why you took this as 2L? Why can't you take L?" That it is not necessary, but I am taking here 2L because in the proceeding steps, some points I have to take half of the dipole length. If I take L, I have to write the half of the length is L by 2. But if I take 2L, I can write this L. So it will make somewhat easy in the calculation. That's why I'm taking this 2L as the length. Okay. So there are two equal and opposite charges which are separated by a small distance. This is called electric dipole. So along with this electric dipole, I have to define a new quantity, electric dipole moment. A new quantity which we are defining, electric dipole moment. What is an electric dipole moment? The definition of electric dipole moment is electric dipole moment. The electric dipole moment is defined as it is a product of any one of the charge and separation between the charges. It is a product of any one of the charge and distance between the charges. It is representing as P. Dipole moment is a vector quantity. It is a vector quantity. It is the magnitude is any one of the charge into distance between the charges. So here the distance between the charges is 12. So Q into 12 is P. It is a vector quantity. The direction of this electric dipole moment is from negative to positive charge. Okay, the electric dipole moment, it is a product of any one of the charge and the distance between the charges, and the direction is from negative to positive. And what will be the unit of electric dipole moment? The unit of electric dipole moment from the definition here, charge, coulomb, unit is there, and length. Coulomb meter is a unit of electric dipole moment. Unit. Coulomb meter. Okay, so it is not centimeter, it is coulomb meter. Charge into length. So next I have to next we are going to discuss. Here we have two charges. One is positive and negative charge, and that is a dipole. So next we are going to discuss electric field due to a dipole at its axial point and equatorial point. Okay, so electric field due to okay, I will write like this: electric field is at axial point of electric dipole. So we have an electric dipole. One is minus q and plus q, which are separated by a small distance. This will be the center, and the total length is 2L, and this length is L, and this length is L. Total length 2L. Total length 2L is there. So I have to find the electric field at a distance x from the center. From center to this point I am writing x comma y, and the distance is x. Okay. So I have to find the electric field due to this dipole at a point xy. The distance between the point and the center of the dipole is x. So when we observe, we can find the electric field due to this plus q charge as well as minus q charge. I'm counting. This is my first charge and this is my second charge. When I see this point, I am putting a test charge here. So the electric field due to the second charge, electric field due to the second charge, E2, is acting away from the point. And due to this first charge, electric field is acting in this direction. Here at this point, I can define two electric field. One is E2 due to this plus Q charge, and E1 due to this minus Q charge. And the electric field due to the plus Q charge, it is acting away from the point, and E1 is acting towards the minus Q charge. So if you see the magnitude, the arrow which I indicate here, the E2 is comparatively greater in magnitude because the distance between the point and this positive charge is less and compared to this negative charge. So the E2 will be high. E2 will be high. So obviously the direction will be the net electric field direction will be along this direction. It's clear because the magnitude of E2 is high. So how to find E net? E net at the point xy. It is simply we have to find the electric field, net electric field. We can write E2 minus E1 because one is away, one is towards. So net magnitude, net electric field will be E2 minus E1. So what is E1? The next step is what is E1? E1 is due to this negative charge. So KQ divided by what is the distance between this minus Q and this point? There is a distance of x plus there is a distance of L. So the next distance is x plus L the whole square. Hope you understand what is a net electric field, what is the electric field even due to this minus q charge. X is a distance between center from the center to the point, and apart from that there is one more L length is there. So x plus L the whole square. So what will be E2? What will be E2? From the center to this dipole is x, but the distance between the plus q charge and the point is x minus L. Here kq by x minus L the whole square. So it is then now it is becoming very easy to find E net. So we can write E net as E2 minus E1 like kq by x minus L the whole square minus kq by x plus L the whole square, right? When I take the common kq by when I take the common kq, it will be like when I take common kq init is equal to kq by 1 minus 1 by x minus L the whole square minus 1 by x plus L the whole square. We have to simplify the equation. Kq is Bahar, so and x plus L the whole square minus x minus L the whole square divided by x plus L the whole square into x minus L the whole square, right? Okay, we can write a plus b into a minus b. So a square minus b square. But here the square term is there. So I can write aq by, when we expand this, I can write x square plus 2xl plus L square minus x square minus L square plus 2xl, right? Divided by a square minus b square the whole square, because here a plus b into a minus b, a square minus b square, but the whole square is there, so I have to write a square minus b square the whole square, right? Something we can get cancel here. This x square term and this x square term will cancel. This plus L square and minus L square will cancel. So net we will get, which is equal to aq into okay 4xl divided by x square minus L square, right? We are getting this equation. But I am making a small arrangement. K into, I'm writing this 4 as 2 into 12. This 4 I split into 2 into 2. So I am getting like this into x divided by x square minus L square. If you see this, q into 2l, this is my dipole moment P. This is my dipole moment P. So I can write 2kp by x square minus L square into x. How up to this it is clear? So what was my equation? E net is 2kp by x square minus L square into x. Here we are going to a small approximation. In the initial time I have told the distance of the dipole, here a minus q plus q. The distance of this dipole is very less, of the order of 10 to the power minus 6, like micrometer or Armstrong. But here the distance from the electric field which is we have to find, it will be in centimeter. So in compare with this, x is very much greater than L, right? 12 or L, it is very much greater, of the order of 10 to the power minus 6 and in centimeter. It is very greater. So I can neglect this L. If L is very small, then L square will be more smaller. So I can neglect this L square term. So now what will the outcome? 2kp by x raised to 4 into x. This x will be there. Here the square term is there. So if I neglect this L, it will become x raised to 4. Can cancel one term. So E net, and finally I can write E net is equal to 2AP by x cube. This will be at the net electric field at axial point. At axial point. Okay, understood? What will be the direction of the electric field? The direction of electric field is in the direction of dipole. Is clear? Direction of electric field is in the direction of dipole. Okay, right? Bus. Okay. Then next we have to find what is the electric field due to this dipole in the equatorial plane. Okay. Yeah. Next is E at equatorial plane. So earlier, as I told, this is our dipole, a minus q and plus q. This is the center. This distance is L, and same as this distance is L. So I have to find the electric field at exactly at the equatorial. So this is x. This line is not straight. Okay. I need electric field at exactly here. This is my xy point. This distance is x. How to find the electric field here? First, we have to discuss what are the electric field acting here. If I see the electric field, this is my first charge, this is my second charge. If I look at this point, the electric field due to this first charge will act towards the negative charge. This will be my E1, right? If I look this plus q charge, this is my second charge, and this is a distance of separation. It will act like this, positive charge away from the point. This will be my E2, right? So the resultant will be in this direction. This is two vectors, so at an angle. So the resultant will be in this direction. We know the direction of dipole is this, right? And what is the direction of E net? Opposite to that dipole. Remember this, the direction of electric field at equatorial plane, equatorial point is opposite to the dipole. Hope you understood. Okay. Then we can talk about the electric field E1 and E2. How to write E1? This is my distance R. It will be equilateral triangle, so this same distance R. If I make this angle theta, I can resolve this will be also theta. By symmetry, obviously this angle should be theta. Then this angle also will be theta. By symmetry, I can say this is if it is theta, this angle should be theta. By symmetry, this is theta, then this angle also be theta, right? So what will be my E1? K into Q divided by R square. This is my R. Now I am taking this as R, that's the distance between the points. E2, say KQ by R square. These two sides are equal. So I can write E1 is equal to E2 equal to E. For the time being, I am keeping E1 equal to E. Then how to find the E net? Either you can use vector product or vector result, and instead that somewhat easy ways resolve these components. Okay, I'm redrawing to here. This is our observation point. This is our observation point. From here, one electric field is going like this. One electric field is going like this, right? And the resultant electric field is this. And this angle is theta. Also, this angle is theta. This is a vector and this is also a vector. So I can resolve the components like this is e cos theta, this is e sin theta. This is my e sin theta for this vector. This is my e sin theta for this vector. You see, e sin theta is our equivalent opposite. So net electric field in the perpendicular direction is 0. Only that electric field is acting in this direction, resultant. That is, one is e cos theta for this and one e cos theta for this electric field. So total E net is 2 times e cos theta, right? So E net, simply we can write E net is 2 times e cos theta. When we substitute to so what is our E net? 2e cos theta. 2 into kq by r square cos theta. From the figure, this is our figure I'm just drawing. So this distance is x, the distance is x. This is our r, and this is the theta angle. Okay. So by using Pythagoras theorem, r square we can write r square is equal to x square plus l square. Similarly, cos theta is equal to L by square root of x square plus L square, right? If I substitute these two into this equation, so E net will be 2kq by x square plus L square into cos theta. Cos theta is L by square root of x square plus L square, right? So if I write E net is, if I can take E into Q into L, as P, electric dipole moment. So that Kp x raised to 1 plus x raised to half, that is x raised to 3 by 2. So x square plus L square, the whole raised to 3 by 2. This is a equation of net electric field in the equatorial plane. If we talk about the approximation, that is E net is Kp by S square plus L square, the whole raised to 3 by 2. The same approximation we have taken earlier, that is x is very greater than L, so I can neglect this L. So this x square and 3 by 2, so x square, the whole raised to 3 by 2, that we can write as x cube. So E net is Kp by x cube. This is a net electric field in the equatorial line. In the equatorial line. And the direction of E net at the equatorial line is opposite to P, dipole moment P. I hope up to this it is clear. Yeah, today the aim was, okay, I'm just concluding here. So today our aim was talk about electric dipole. The electric dipole is two equal and opposite charges which are separated by a small distance. Then we defined electric dipole moment P. It is product of any one of the charge into the separation between the charges. Unit coulomb meter ആണെന്ന് കണ്ടു. Then we move on to the calculation of electric field at axial point and equatorial point, and finally we received the expressions like this. Electric at the axial point is 2 kp by x cube. The direction is along the dipole moment, but in the case of equatorial plane, the expression is E kp by r cube and opposite to electric dipole moment. Okay, right?